Hello everyone. So welcome to this lecture video. This is for sample problem from 161 to 170. So for this problem we want to find the expected current payment. Okay, we want to find expected payment. So what is the payment? Okay, so payment is deductible is 1. So the loss follow exponential distribution. So this x follow exponential distribution with mean 1 over lambda, mean is 2. Okay, so deductible is 1. Okay, so payment, so between here is pay 0, here pay x minus 1, right? So we want to find expectation for payment. Let's say we denote y as payment. Okay, y as pay. Okay, so this equal when x larger than 1, so for x from 1 to infinity, the pay is x minus 1, right? And then lambda is negative lambda x dx. So for this integration, so we use substitution, we let x minus 1 equal t. So this integration becomes from 0 to infinity. So this is t lambda e negative lambda. So this x is t plus 1. T, right? So we take negative, take this negative lambda outside, negative lambda. And then this is from 0 to infinity, t lambda is negative lambda t dt. Okay, so for this part is just as expectation for this. So this just is negative lambda. This is just actually the expectation for x, right? So we know the answer is negative lambda. So expectation is 1 over lambda. Okay, so what is the lambda? So 1 over lambda equal 2. Okay, so lambda is 0.5. So this equals the 1 over lambda is 2 is negative 0.5. So for this problem, we want to find the variance of those. So variance of those, so x plus y over 2 over 2. So at the first over 2, we put 1 over 4 outside, right? So this become x plus y, this variance. Okay, so this is joint density function. So we just according to definition, so the variance for this equal 1 over 4 z square x plus y square minus z square x plus y. So let's do some calculations here. So here let's say x plus y. So this equal just this region, so x plus y, that's the function dx dy. So let's check D. What is D? D is x between 0 to 2, y between 0 to 2. So D is just this square, right? So from 2 to. And the density function fxy is x plus y over a. So this equal, so we can take a on the side, x plus y. So here also x plus y is x plus y square dx dy. So just do those calculations. So let's say this calculation actually is easy, right? Because this region, integration region, this d is a square, so this equal like x from 0 to 2 dx. So y also from 0 to 2, so x plus y square dy, right? Okay, so this integration equal, so dx. This integrated out, so we got x plus y as t, like t square. So okay, so this equal x 2 plus y square. No, x fixed, yeah. So x plus 2, this is 3 minus x3. So dx. Okay. So this equal 24, 0 to 2. So x plus 2, 3 minus x3. So this equal like 3x2 times 2 plus 3x2 square. So plus 2, 3, right? Yeah, 2, 3 is 8. So dx. So for x, so x plus y square is same, right? So x plus y square, so the same way. So this I think equal just 1 over a 0 to 2 dx. So this just become x plus y 3. Just this integration. Okay. So after some, so this one, so again the same way, right? So equal, so this 3 is 1 over 4. So this is equal this, right? Dx, so this equal, this 4. So x, the dy, so x fixed, x plus 2, 4 minus x4. Okay. Dx. So here maybe we need to use the formula like x minus plus 2, 4. So equal x4 plus 4x3 times 2 plus 6x2 and 2 square, right? So plus 4x multiply 2, 3, 8. So plus 2, 4, 16. So by now, those problems just the integration math problem. Okay. So for this problem, we want to calculate n. So what is n? So we have this test, have 40 questions. The probability that this student answer correctly is 0.5. So 0.5, 0.5. So number of correct answers. So the x number of correct answer. So this x we know this follow binomial distribution. Right? So, n is 40 and p is 0.5. Right? So we say n equal 40, p equal 0.5. So we want to find this n such that n such that larger than n, this one is probably larger than 10%, and larger than this is less than 10%. So we want to find source n. Okay, so for binomial distribution, so we use normal approximation. So we have this result. This binomial distribution will close to this normal distribution. So means NP variance NPQ or standard deviation is this, right? So apply to here. Says follow this normal distribution, mean is 20 and standard deviation 40 times 0.5, take square root, this is radical 10. Okay. So this probably like x larger than or equal n. Equal this n. So we should so this is a discrete distribution. So in order to guarantee, like in order to include this, so we should move a little bit, like smaller. So this equal like x larger than n minus 0.5. Okay. So we wanted to make this is larger than 10%. Okay. So let's check where is 10% cutoff point. So if we regard this as just the continuous normal distribution, so let's check this. We want to find the cutoff point such that x larger than a exactly equal 10%. So this one, so we change into standard normal. C larger than, so a minus 20 over radical 10, right? So this equal 10%. So from normal table we can find this cutoff point. Like here, this is normal, and here's 0. We want to find a cutoff point such that this is 10%. This means this less than 90%, right? And here is 10%. So from the normal table, we can find this cutoff point should be 1.28. So we just let this a minus 20 over radical 10 equal 1.28. So we can find a equal 20 plus 1.28 multiply radical 10. So this is just equal, we find 24.04 like this. Okay. So let's say, so there's a cutoff point just like 24. Okay, so let's say, so 24 is, so okay, so there's 23. So this is like so means like 24 is 10%. So okay, so we let it n equal 24. n equal 24. But if n equal 24, we should check this. Yeah, n equal 24. So yeah, this will be larger than 10%. So n equal 24. And okay, so let's check answer. So answer says we do not have 24. So just only check from 23 and 25. So we find if n equal 25, if n equal 25, so 25 not okay, right? If n equal 25, so larger than 25, so this is not less than not larger than 10%. So our answer we just pick 23. For this problem, we want to calculate the probability that exactly we have two those things happen during July to November. Okay, so we want to find this probability, like n equal to. So what is n? N is number of accidents during this time period. So we know those number of accidents follow Poisson distribution. Okay, so this is like if from like June and July and August, those number is Poisson distribution with means 1. And so other months, this is a Poisson distribution, and but the mean is this. Okay, so from the July to November, so we just check these 5 months. So these 5 months, the number of accidents follow Poisson distribution. Poisson plus Poisson is Poisson. And the mean, so here is 1, 1, 1. Here's 0.5. July, August is 1. And this is 0.5, 0.5, 0.5, right? So mean is 3.5. So such a probability is very easy. This equal, use the formula, is equal lambda k over k factorial is negative lambda, right? So here k equal 2 equal lambda 2 over 2 factorial is 2 is negative lambda. So what is lambda? Lambda is 3.5. So that's equal 3.5 square over 2, then is negative 3.5. Okay, so then use calculate, we can find this. So this problem we want to find standard deviation for those things. So from moment generating function, right? So from moment generating function, let's say from moment generating function, we want to find variance, like find sigma square or find sigma. So this sigma or this sigma square, we say this equal mu2 minus mu1 square. Okay, So from moment general function to moment, so we have this, right? Mu1 is first derivative moment. Then we let t equal 0. And mu2 is second derivative. Let t equal 0. Okay? So we just find, let's say we want to find the moment generated function of x plus y. So we want to find the moment generation function for x plus y. So the first we have this, the moment generation function for x plus y is moment generation function for x multiply moment generation function for y. So here, this x and y, it says the same thing, same. This x, y are identically distributed. So this means like there's moment function the same. So we find this moment, this one is this. So we say this moment function equal, it's multiply together this equal this 4. Right? Or we put this 1 over this 4, so we just put this for derivative, so we just put this as 1 minus 1.5t negative 4. Okay, so now we can find mu1, mu2, right? So mu1 equal, so negative 4, since negative 5, then multiply negative 1.5. So let the t equal 0. So we find this equals 6. 4 times 1.5, right? So mu2 is second derivative. So this actually equals 6. Then 1 minus 1.2t negative 5. This is first derivative, right? So for derivative again. So this equal 6 times negative 5. Then this negative 6. Then multiply negative 1.5. So let t equal 0. We find this equal 30 multiply 1.5, so equal 45. Okay, so the value is sigma square equal 45 minus 6 square equal 45 minus 36 equal 9. Okay, so this sigma equal 3. So here we want to find standard deviation for this amount of paid. So let's check a paid. Suppose paid. So paid. So we need to check a pay for so much. Okay, so here we need to be careful of pay. Suppose it's y. Okay, so we want to find the distribution for y. This y pay. So let's pay. Let's say for every 14 inches of snow in exceed of 40 inches, then they will pay 300. Right? So let's say, so if snow, maybe, so we need to check snow. If snow is, let's say, snow is, so exceed 40, yeah. So exceed 40. 14 equals 40. So they pay from 50, right? So if like 50 to 60, so from 50 to 60, they will pay $300. Okay, and from 60 to 70, they will pay $600. Right, and then above 60, from 60 to infinity, 70, from 70 to infinity, they will pay at most pay $700. Then for other case, the less than 50 pay 0. So if this is less than 50, like if snow is let's say if like snow is 45 inch, the company will pay or not pay. On 14 inch of snow. Yeah, so here the keywords here. 14 inch of snow in excess 40. So if the snow is 45, they will not pay. Right? Okay, so we can easily find the source. So probability for y. So this case from this case is 14%, right? 14, and this is 6, and then this is 008, and then here's for all others. So here 1472, right? Okay, so now this so we can find sigma. We need to find variance, right? So this is just do some calculation. So do quickly. So y square. So we need to find y square is y. Okay. So y squared, this square multiplies probability. Yeah. Okay. So for this problem, what we want to find this. Let's say the policy we have deductible. Say here 20. Deductible is 2. Okay. So we find this car was involved in a crash with resulting damage in excess of a deductible. So this means this condition that this damage is larger than 2. Okay, so we want to find this probability. So the damage is exceed 10. So this is actually a conditional probability. We need to find this probability. Like, okay, we want to find this larger than 10, giving that x larger than 2. Like this is a conditional probability. So this one equal x larger than 2. So here x larger than 10 and larger than 2. So larger than 10 also include larger than 2, right? So we just find this probability. So to find this probability, so let's check this. X larger than a. Okay. So x larger than a. So we say this equal the integration from, let's say, from a to 20. Saying this is density function. So C says x squared minus 60x plus 800. So x squared plus minus plus minus minus 60x, okay, plus 800 dx. So we can integrate out. So this equal 1 over 3 23 minus a3 minus 60 x integrated out 1 half, so 20 square minus a square, so plus 800, so here 20 minus a. Okay, so for those the px larger than 10 over px larger than 2, so we can forget the c, so just plug it in, right? So x equal 10, we plug a equal 10, so then a equal 2, so we just do this calculation, right? Okay, so forget the t, forget the c, we can find this number. Let's say that when a equal 10, what is this number? Then when a equal 2, what is this number? Okay. So such a problem, determine which of the following is true. Also, so such a problem, so quite confusing. So for me, I just give up. Okay. Because we need to check this case, just take time. Okay, so for this problem, we want to calculate the probability that a 6 is load both time. So we just we want to find this probability. We get a 6, first one 6, second one is 6. Both time we get a 6. Okay, the story is we pick, so here we pick a die and load it twice. So what is the chance we get the 6, 6? So this is the die we have. Let's say we have 4 those deals, and 2 like just like we have like 2 dice. Those are regular one. So 1, 2, 3, 4, 5, 6. But for this one, is we have this die is 2, 2, 4, 4, 6, 6, and for this one, all are 6, 6, right? Okay. So we just pick from them, pick one randomly. So we have this case. If we okay, so there's a probability if we get this one, so that's such chance 2 over 4, right? Then we get first one 6, second one is 6, 1 over 6, 1 over 6, right? So plus if we get this one, so such chance is 1 over 4, and so we get 6, we get 6, 1 over 3, 1 over 3, right? And saying plus if we get this one, so 1 over 4. So if we get this one, first one 6 is 1 always, right? The second one is 1 always. So this is the answer. Okay. So we want to calculate the probability that we get two others, and two others. Okay, so we just take 6. So totally we have 12. So among the 12, so totally we have 12. So we just split 12 into parts. So some 6 into the auto insurance. So 6 auto insurance, and these 4 are interested in home insurance, and these 2 are only interested for life insurance. Okay, so there's probabilities just from each part. We just pick 2. So here we just pick 6 randomly, and here from this part pick 2, and from this part pick 2, and from this part pick 2. Right? So the probability is just that. So simple. So here we just need to do some calculation, like for example, of 6 choose 2 equal what? Equal 6 times 5. So 1 times 2 equal 15, right? And 12 choose 6. So this equal to 12 times 11 times 10. Just multiply 6 number. 987 over 1, 2, 3, 4, 5, 6. So we can, let's say, cancel 6, 2, 12 cancelled, and cancel 3, and cancel 4, and cancel 5. So we find this equal just 11 times 7 times 2 to 4 times 12. Okay. So just some calculation here. Okay. Okay. So those are problems from 161 to 170. Okay. So we can stop here, and so thank you for your watching.